Let's look at the epoxidation of an alkene with a peracid, and I want to focus on why we get different products depending on the isomer we start with. For instance, in this example, if we start with the trans 2-pentene, I get an epoxide where the methyl group and the ethyl group are trans to one another, whereas if I start with cis 2-pentene, I get a product where the methyl group and the ethyl group are cis to one another. And in order to do this, in order to see what's going on here, I want to look at the structure of this alkene from a slightly different perspective. So if we focus on the trans alkene first, I want to look at it from the perspective shown here, where this hydrogen and this ethyl group are coming straight out towards me, and this methyl group and this hydrogen are going back away from me. Now, when we get the epoxidation reaction to happen, an oxygen atom can come in from either above or below the plane of this molecule. We're going to look at the oxygen coming in from above, and I'm not going to worry about the movement of electrons on this reaction and how the peracid actually donates one of its three, I've only shown two here, but there are three oxygen atoms to make my epoxide. What I want to focus on is the fact that all of the bonds that get made are broken. So one bond is broken and two bonds are made. That all happens simultaneously. And we can look at this in a little bit more detail if I take my 3D model. So this right here is this right here. And this other model is rotated just like this. And this oxygen is, the way I've drawn it, above my double bond. So here's my oxygen. You can see it's right above that double bond. And since all of the bonds are made simultaneously, the two new bonds are made, there's no time for the relative position of these two groups, my methyl group and my ethyl group, to change locations. Since they're trans to one another in my alkene, when I form these new bonds, they'll be trans to one another in my epoxide. And you can see I've formed my epoxide, and those two groups are still trans to one another. Do a similar analysis for the epoxidation of my cis alkene, where again I want to take this molecule and view it so that the methyl group and the ethyl group this time are both coming out towards me, and both these hydrogens are going away from me. So if I look at my 3D models, again, my methyl group and my ethyl group are cis to one another. This is a representation of this. And when I go from here to here, this rotates like this, so that I get something like this. Now again, the oxygen is going to come in from either the top or the bottom. Again, we'll look at it coming in from the top. And again, the two bonds that get made and the one that gets broken, all of this happens at the same time. So because of this, since these are cis in my reactant, they are also going to be cis in my product. And that's what we can see here. These two groups are cis to one another as they were in the reactant.